Some examples of sequence of limit. So first example is using Epsilonian definition. Prove that the sequence here sequence is given that 10 raised to 7 divided by n. Okay, sequence is given that 10 raised to 7 by n has n runs from 0 to infinity. Okay, so n runs from 1 to infinity, has limit is 0. Okay, has limit is 0. Using to show Epsilonian definition. Okay, using this definition to show that this sequence has a limit is 0. Okay, so solution of this sequence, let sequence Sn is n runs from 1 to infinity is given that 10 raised to 7 divided by n. Okay, n runs from 1 to infinity, that is Sn is 10 raised to 7 divided by n. And to show that, here to show what is our claim is limit n tends to infinity, Sn is equal to 0, that is limit n tends to infinity 10 raised to 7 divided by n is equal to 0. Here we have to show using epsilon n definition. Okay, so by using epsilon n definition, what is epsilon definition is? Epsilon definition is for all epsilon greater than 0 there exist or we have to find. Okay, we have to find capital N belongs to I, n belongs to index set I, such that mod Sn minus L is less than epsilon for all n is greater or equal n, or whenever n is greater or equal n. So using this definition, so consider mod Sn minus L is less than epsilon, and then we have to find this n. Okay, this n is less equal this n. Okay, so consider we have to show sequence Sn has limit is 0. So consider Sn minus L is equal to Sn is 10 raised to 7 divided by n, and their limit you have to show limit minus 0 is less than epsilon. So considering, okay, which imply that 10 raised to 7 divided by n, 10 raised to 7 divided by n is less than epsilon, which imply that 10 raised to 7 divided by n is less than epsilon, which imply that 10 raised to 7 divided by epsilon is less than n. So choose n is equal to capital N is equal to, so choose capital N is equal to this value 10 raised to 7 divided by epsilon, this value is strictly less than n. So which implies that 10 raised to 7 divided by epsilon plus 1 is less equal n maybe. Okay, so choose n is equal to 10 raised to 7 divided by epsilon plus 1. Okay, why this is n is choosing 10 raised to 7 divided by epsilon plus 1? Because here condition is greater, n is greater equal n, means capital N is greater equal small n. Okay, so choosing this integer, then n has a value is always less equal, this n has value is less equal capital N. So we have to choosing this n is equal to 10 raised to 7 divided by epsilon plus 1. Okay, so n is greater equal capital N. Therefore by definition of here n, this n is exist in this set, this capital N is exist in this set 10 raised to 7 divided by epsilon plus 1. So by definition of epsilon n definition, for all epsilon greater than 0, there exist n is equal to 10 raised to 7 divided by epsilon plus 1. 10 raised to 7 divided by epsilon plus 1 belongs to I, such that mod Sn minus 0 is equal to mod Sn value is 10 raised to 7 divided by n minus 0 is less than epsilon when n is greater or equal n. Okay, therefore by definition of epsilon n definition, limit n tends to infinity 10 raised to 7 divided by n, 10 raised to 7 divided by n is equal to 0. This is our solution. Means given sequence has a limit is 0 at n tends to infinity. Okay, this is one example. So then next example by using epsilon n definition. Next example, by using epsilon n definition, prove that the sequence whose nth term is sequence Sn is equal to n trans from 1 to infinity is equal to minus 1 raised to n. Okay, sequence is given that minus 1 raised to n has no limit. Okay, here to show that example says that by using epsilon n definition, show that this sequence minus 1 raised to n has no limit by using epsilon n definition. So how to proving there this sequence minus 1 raised to n has no limit? So considering their proof is by contradiction. Suppose that there has a limit L, then we have to show lastly contradiction. Okay, so solution of this, let given that sequence Sn n runs from 1 to infinity is minus 1 raised to n, where n runs from 1 to infinity. Okay, sequence Sn is given that, and to show sequence Sn has no limit. We have to show sequence Sn has no limit. Okay, so proof by contradiction. Proof by contradiction means to suppose that given sequence has a limit. Okay, and to show that lastly we get a contradiction to our assumption. Okay, so proof by contradiction. Suppose sequence Sn n runs from 1 to infinity has a limit L. Suppose that given sequence has a limit L, means this sequence is given that minus 1 raised to n. This sequence has a limit L. Say that L is any number. Okay, so means sequence Sn has a limit L, which implies that by definition of by epsilon n definition. Okay, that is n tends to infinity, Sn is equal to L. Okay, so by epsilon n definition, this sequence Sn has a limit L, which implies that by epsilon definition, for all epsilon greater than 0, there exist n belongs to I such that mod Sn minus L is less than epsilon whenever n is greater or equal capital N. Okay, so this sequence Sn has a limit L, which implies that we satisfy this sequence satisfies this condition mod Sn minus L less than epsilon whenever n greater or equal n. Means here at least one of the element is exist, n belongs to I such that we satisfy this all condition. Okay, means if we satisfy this condition, then sequence limit n has a sequence has a limit L. Okay, here given sequence has limit L, which implies that by definition this sequence satisfies mod Sn minus L is less than epsilon. Okay, so suppose mod Sn minus epsilon, so this is equation number 1. Okay, here sequence Sn sequence Sn is equal to minus 1 raised to n, which implies that if or when n is even, then sequence Sn is 1 only. Okay, if n is even, then minus 1 raised to n is even number, then minus 1 raised to any even power, then their value is 1. Okay, so Sn is equal to 1. Then take epsilon is equal to 1 by 2, which is greater than 0. Okay, taking epsilon is equal to 1 by 2, their value is greater than 0. Therefore equation 1 becomes, therefore this equation 1 becomes, putting the value of Sn and epsilon, we get 1 minus L is less than 1 by 2. Okay, 1 minus L is less than 1 by 2, where n is greater equal n. Okay, so suppose that this equation number 2. Okay, then next condition, when n is odd, then Sn is equal to minus 1, because minus 1 raised to any odd power. Okay, minus 1 raised to any odd power, then their value is minus 1. Okay, and then again take epsilon is equal to 1 by 2, which is greater than 0. Then equation 1 becomes is minus 1 minus L is less than 1 by 2, n is greater equal n. So which implies that minus 1 into 1 plus L, we have to, here minus sign is common, minus 1 is common, then 1 plus L. Okay, and this is 1 by 2, where n is greater equal n. So which implies that mod of minus 1 into mod of 1 plus L, is less than 1 by 2, since mod AB is equal to mod A into mod B. Using this result, mod of minus 1 into 1 plus L is equal to mod of minus 1 into mod of 1 plus L. Okay, n is greater equal n, and mod of minus 1 value is 1. Okay, their value is 1 into mod of 1 plus L is strictly less than 1 by 2 when n is greater equal n. Okay, since mod of minus x is equal to x in real number. Okay, so here suppose that, which imply that mod of 1 plus L is less than 1 by 2, n is greater equal n, and suppose this equation number 3. Okay, this equation number 3. So here equation number 1 is Sn minus L is less than epsilon. When n is even, then we get this equation number 2, and when n is odd, then we get equation number 3. Okay, but we know that 2 is equal to mod 2. Here mod 2 is expressing in the summation 1 plus 1. Okay, 1 plus 1, but here 1 plus 1 is 1 plus L. We are adding and subtracting L. Okay, 1 plus L minus L plus 1 as it is. Okay, then here only adding and subtracting L. Okay, we get the answer is 2. Okay, then which is here mod x minus y is less equal mod x plus mod y. Okay, using this result mod x minus y is less equal mod x plus mod y. Using this result, so here mod 1 plus L, plus, and here minus sign is here multiply, so their value is 1 minus L. Okay, so using this, or this is written in the form of 1 plus L, minus sign is common, 1 minus L. Okay, 1 plus L minus 1 minus L, and then their modulus, this term is less equal for this term. Okay, this term is less equal for this term. So value of 1 plus L, value of 1 plus L is strictly less than 1 by 2, plus value of 1 minus L. So from equation 2, value of 1 minus L is strictly less than 1 by 2. So putting their value, and here their value is 1 by 2 plus 1 by 2 is equal to 1. Okay, therefore 2 is strictly less than 1. This is not possible. Okay, which is impossible. This is impossible, and therefore 2 is strictly less than 1. This is a contradiction because 2 is not always less than 1. Okay, and this is a contradiction, so which is impossible, we get a contradiction. And therefore here contradiction is exists. Therefore our assumption was wrong. Here our assumption is sequence Sn has a limit. Okay, sequence Sn has a limit is wrong. Okay, our assumption was wrong. Therefore sequence Sn, where n runs from 1 to infinity is equal to minus 1 raised to n, has no limit. Okay, this is a proof of our example. How to proving? Only to show that by using epsilon n definition, when n is even, then put their value is 1, and when n is odd, then put their value is minus 1. Okay, and take epsilon is equal to 1 by 2 in both cases. So using 2 and 3 equation here, by equation 2 and 3, consider 2 is equal to, and express 2 is in the form of 1 plus 1, then add and subtract L. Okay, adding and subtracting L, we get a 1 plus L minus, here sign is common, then 1 minus L. Okay, and then use this result, mod x minus y is less equal mod x plus mod y. Using this result 1 by 2 plus 1 by 2, and we get 2 is less equal 1. This is not possible. So which we get a contradiction to here, 2 is less than 1 here exists, so which is not possible, and this is a contradiction. So our assumption was wrong, and therefore our assumption is given sequence Sn has a limit L. This is wrong, which implies that given sequence has a no limit. Okay, so this is one example. Then next example, similar example, show that the sequence n is equal to, show that the sequence n, where n runs from 1 to infinity, has no limit. Okay, has no limit by using epsilon n definition, means limit of sequence. So how to prove this sequence also has no limit? So their proof is also by contradiction. Let sequence Sn is equal to n, where n runs from 1 to infinity. Okay, and to show that here Sn has no limit. Sequence Sn has no limit. Okay, proved by contradiction. proof by contradiction. Suppose given sequence Sn has limit L, say, okay, suppose that given sequence Sn has a limit L, okay, so therefore by epsilon n definition, for all epsilon greater than 0 there exists n belongs to I such that this sequence satisfies the inequality mod Sn minus L is less than epsilon whenever n is greater or equal n, okay. Therefore putting value of Sn we get putting value of Sn we get putting the value of Sn we get therefore mod Sn minus L is equal to n minus L is less than epsilon for all n is greater or equal n, okay. But here we taking epsilon is equal to, take epsilon is equal to 1, then mod n minus L is less than 1, okay, for all n greater or equal 1. We here mod x is less than 1, there this means that mod x means x is lies in between -1 and 1, okay. So using this result n minus L is less than 1, which imply that n minus L is lies in between -1 and 1, so -1 is less than n minus L is less than 1. So using this result, if mod x is less than 1, then this means that x is lies in between -1 and 1. So using this result, n minus 1 lies in between 1 and -1, which imply that here adding L in both sides, we get L minus 1 is less than n minus L plus L less than 1 plus L, which imply that L minus 1 is less than 1 plus L, okay. But which implies that -1 plus L is less than n is less than 1 plus L. This statement says that all values of n is lies in between -1 plus L and 1 plus L, okay. Means all values of n are lies in between -1 plus L and 1 plus L, but this is impossible when n is very large. This is n. If n is equal to suppose that infinity, then this is not possible, no? Okay, this inequality not satisfy n. Therefore this statement last statement says that all values of n is lies in between -1 plus L and 1 plus L. Means values of n are in between -1 plus L and 1 plus L. So which is not possible but for large value of n, which is not possible, or above inequality not possible, okay. Above statement or above cases fails. Okay, suppose that their equation above equation star is fail. Okay, above equation star is fail, and therefore we get a contradiction. Because L is a finite number, and if we putting n where n is a runs from 1 to infinity. Okay, n has an infinite value, sequence Sn has an infinite value, and L is a finite number. Then their value is for large n. There is n is not lies in between. N is value of n is not belongs to -1 plus L and 1 plus L, means does not belongs to in between -1 plus L and 1 plus L, so which is a contradiction. Therefore sequence Sn is equal to n has no limit. Okay, this is our example. Then similar way to show that, next example, similar way, prove that the sequence n divided by 10 raised to 7, n runs from 1 to infinity, has no limit. Okay, prove. How to proving given sequence has a no limit? So sequence here, let sequence Sn is equal to n runs from 1 to infinity is given, n divided by 10 raised to 7. Okay, n runs from 1 to infinity, this sequence is given. Okay, so to show what to show here, sequence Sn has no limit. How to show? Proof by contradiction. Again similar way, proof by contradiction. Suppose that sequence Sn has limit. Sequence Sn has limit L. Okay, suppose that given sequence Sn has limit L, say that then by epsilon n definition, for all epsilon greater than 0, there exists n belongs to I such that mod Sn minus L is less than epsilon for all n greater or equal n. Okay, therefore putting value of Sn is given that n divided by 10 raised to 7, and their limit is L, which is less than epsilon for all n greater or equal n. Okay, so take epsilon is equal to suppose 1, there which is greater than 0, then n divided by 10 raised to 7 minus L is less than 1, which implies that minus 1, their value is lies in between minus 1 and 1. Okay, means minus 1 is less than 1 upon 10 raised to 7 minus L less than 1, since mod x is less than 1, which implies that minus 1 lies in between, value of x is lies in between minus 1 and 1. So here minus 1 is less than n by 10 raised to 7 minus L is less than 1. So adding here L, we get minus 1 plus L is less than n divided by 10 raised to 7 is less than 1 plus L. Okay, so multiply 10 raised to 7 in all, therefore 10 raised to 7 into minus 1 plus L is less than n is less than 10 raised to 7 into 1 plus L. But this statement, the equation star In similar way, the equation star says that all values of n. The equation star says that all values of n lies in between 10 raised to 7 into minus 1 plus L and 10 raised to 7 into 1 plus L, but for large n equation star fails, or last statement is fails. Okay, therefore we get contradiction. Okay, and therefore our assumption was wrong. Means our assumption is given sequence has limit, so their assumption is wrong. Therefore given sequence Sn is equal to 10 raised to n divided by 10 raised to 7 has no limit. Okay, this is our solution of given sequence. In this way, solve any sequence of limit exists or not. Okay.